Good day everyone. We'll have a look today at some soils out of the east coast of Australia, more specifically the Maryborough irrigation area, water sourced from the Mary River. We've been taking soil samples on a grid basis in these properties. The grid samples are 70 meters apart, and it's mainly on new macadamia plantings that's been established on old cane farms. The first map we'll look at is a pH map of the first property that we're analyzing. You can clearly see that there's big variation in the pH on this property, and with big sections, about 30% of the property at a pH of under 4.5 calcium chloride. At this pH range, aluminium is soluble and most of our other elements are not. Very low potassium solubility, and this is affecting a lot of nutrient uptake in the property. You can also clearly note that there are areas, it's about 11% of this total farm, that the pH range is actually fine, sitting between 5.5 and 6.5. So again, big variability over a very short distance, fairly light soils with a lot of water movement through them. The next map's a sulfur map. Sulfur is a very mobile element, gives us a good indication of where we have waterlogging in a property, and there's a clear waterlogging spot in the northern end of this property. So again, using nutrients to identify issues on the property. Acid saturation is a ways to indicate where we will most likely find aluminium toxicity. Very interesting, half of the southern block is totally acid and very high chance of aluminium toxicity, resulting in phytophthora and other root diseases. Not possible if we would take this as an average soil test. This might very well not have been picked up, and that's the advantage of doing grid sampling. The next map we look at is a calcium percentage. That lower section is obviously still very deficient in calcium. But interesting, we've got some areas turning blue on the map, showing nearly excess calcium levels. So we do need variable rate sampling on grid sampling and variable rate application to actually fix these variabilities and give the trees optimal growth. Moving on to our application maps. These maps are what's loaded into the variable rate spreaders. You can see lime application map. On this property there is about 10 hectares that don't get any lime. Doesn't need it, so we don't apply it. Sorting out the potassium variability, potassium sulfate used on a variable rate application. At this property we're only applying 50% of total requirement, and it's being band placed on the mounts to save costs. Property number 2, pH map, same thing, very big variability. pH ranges from 6.5 all the way down to below 4.5 calcium chloride. Potential high areas of aluminium toxicity that will show in some later maps. Looking at the calcium percentage map, it's clear to see that the low calcium levels are part what's driving the low pH levels. Big variability in calcium percentage. You'll see in the lime recommendation maps, we're fixing that variability up with variable rate applications. This has got a major impact on growth of new trees with low calcium, resulting on low ability to divide cells in these trees. Acid saturation or exchangeable acid maps. These maps show us where the aluminium toxicity will be most prevalent, and clear spots in this property that we've got to address and lift the pH in these areas so that the aluminium doesn't burn and affect the roots and allow secondary phytophthora infestation to come in. Potassium percentage, also big variation, same thing like in most maps that we find, especially in the Maryborough area. Potassium percentages range from about 10% all the way down to nothing. Potassium's got a major role to play in the water management of plants. If we don't have enough potassium, the stomata cannot function optimally, and we get plants that really stress quickly with water stress. One of the very interesting maps that we produce is a sodium percentage over potassium percentage map. This map indicates where the ratio of sodium to potassium is incorrect. Since plants take sodium and potassium up at exactly the same rates, we need this ratio in the soil to be the right way around. If it's not, we get very detrimental plant growth restrictions, plants taking up sodium much more than potassium and suffering the consequences. With this map we can go and address the problem areas that's clearly identified and alleviate this problem from the soil. Moving on to some of the variable rate application maps for this property, you can see there's a lime recommendation map. 60% or 60 hectares of this property is getting a lime applied to out of the 80. So we've got 20 hectares that get no lime, that doesn't need any lime. The rates, like you can see, go up there all the way up to 12 ton in some of these hotspots, but reduces down to with 1.5 ton a hectare rate in the lower areas. Variable rate gypsum applications mainly targeted to leach the sodium out of the soil profile to fix that sodium potassium ratio map that we saw earlier. We'll also bring some extra potassium into the system to help with that ratio. You see most of the property doesn't need gypsum, it's only those high sodium spots where we apply gypsum. Then following on to our potassium application map. Potassium application is only done on 49 hectares out of the 80. A lot of this potassium is also there to get that sodium potassium ratio correct to help our plants to perform optimally. In this property we only apply 25% of the total requirement due to low pHs, and it's also band placed on the mounts. So, analyzing variable rate versus an average soil test, I think it's clear to see that in order to identify soil issues and problems, we need to do more intensive soil sampling. Grid soil sampling is an ideal tool to identify all these hotspots and problem areas, and then variable rate application of ameliorants enables us to make the soil an even playing ground for our trees to grow in. Thank you for watching, and I'm sure I'll be seeing you on your property soon doing some variable rate soil sampling.